I will share with you part of my work and of my colleague Ana Barbosa, that is here present, about visual solutions as a powerful strategy to solve problems where we made a teaching experience with using a gallery walk with pre-survey teacher. We are both elementary mathematics teachers at School of Education at the Politécnico Instituto Viana do Castelo in the north of Portugal. We propose this agenda where I began with an introduction, then the theoretical framework, the study, and final some concluding remarks. As teacher educators, we believe that learning requires an active and reflective engagement on the part of the students in solving meaningful, diverse and challenging tasks. And for much of the students, teachers must encourage perseverance in problem solving and support their productive struggle in learning mathematics. So we need accord different organizations to promote the development of student skills. Some proposed by for the first 21st century that are called the 4 C's. The 4 C's, and the 4 C's are the critical thinking that students make to achieve best solutions, communication, they have understand and share ideas and thoughts, collaboration, they must working together and to make decisions, and creativity. They must develop opportunities and have opportunities for new and efficient approach. In this perspective, the tasks used in the classroom are the basis for all students' learning. And we can consider a good task the one that serves to introduce fundamental mathematical ideas. It's an intellectual challenge and that students want to overcome and allows different approach. The tasks are important in our work where we privilege multiple solutions that allow different solutions, including one that must be the visual one approach, because in class we have students with different ways of thinking. And as Krutewski and others suggest, there is two types of thinking, the verbal logical and the visual pictorial. And the balance between these two ways of thinking determines how mathematical ideas operate in an individual, that have implications in the performance of students when they solving a problem. So we can have 3 types of students: the analytical, verbalizers, or no visual, those who prefer to use verbal logical modes of thinking. In the opposite side, we have the geometric, the visualizers, or the visual, those that prefer to use visual pictorial modes of thinking. And in the between, there are those that no have preference for either logical, verbal, or visual pictorial, and we call harmonic or mixed or the integrators. I can show you an example. This kind of problem, for instance, we ask for present more than one resolution in the expectation that students choose a visual one. This is a normal problem that we want to know the ratio of the areas between the 2 triangles. This is a typical resolution of this kind of problem that involves many relations, formulas, concepts, and look for these relations. It is not easy for elementary students, but it will be easier to solve this problem, if we saw the triangular, the little triangle in another position, and after we get immediately the solution that was 1/4. This is what Presme called a visual strategy using a dynamic solution, or as Krutevsk says, that this kind of visual solution is simple, clear, and elegant, or as Lishdal said that students have aha experience. So we learn to think visually or sing, and therefore you can also teach it, and it is important to teach it. And tasks with visual characteristics can help students to overcome some difficulties with contents and procedures, solving the tasks with success. In addition to the tasks, teachers must have a practice that engage students, but more recently, we are worried with an aspect we want to mention here, and that it is that passive learnings and sedentary behaviors highlight prevalent young people in and out of school that influence on the teaching and learning process. Studies in the field of the neuroscience draw attention to the movement, manipulation, and experimentation that allow students to be attentive, improve understanding and memorization. This imply what you call active learning, that engage students in a learning processing, learning by doing and thinking, and emerge from experience and effective interactions between 3 dimensions, the cognitive, the social, and the physical one. In this sense, we can summarize these ideas saying that effective teaching of mathematics engage students of all class in solving tasks that promote mathematical reason and allow multiple approaches. Teachers should develop the forces through an active learning. The use of visual image is an important support for all kinds of problems, even those where the visual component is not evident. And teachers should promote the use of posters as an important tool that enables visualization to foster students' learning as a key component for cognition. And here you propose a gallery walk strategy for math classes. We consider a gallery walk as an instructional strategy that allows students to solve multiple solution tasks collaboratively, displayed in posters around the classroom or outside the classroom, having the opportunity to give and receive feedback and discuss ideas collectively. One aspect to note is that all the dynamics of a gallery walk is developed around the creation of posters. Posters are a visual communication to connect with the nature of the knowledge used in our high-tech daily lives, based largely on image full of information, and posters encourage students to share and reflect on learning and enable them to learn from other students' ideas. So we develop a study where we pretend to identify the strategy used by the pre-service teacher when solving tasks with multiple solutions, in particular to identify the visual ones and characterize the reaction during their engagement in a gallery walk experience. You use a qualitative approach with 14 preserved teachers of basic education, in the class of didactics of mathematics, the data collection, for the data collection we use observation, photos, written productions, mainly task solution, the construction of posters and the comment, the post-its. And for the data analysis, we consider two main categories: the different solution used by students and their reaction to the experience. The gallery walk that we use have 6 steps that are this one. The first one is to solve the proposed tasks. In this case, in pairs, they solve 2 problems. Then they have to construct the posters. They discuss the resolution and the presentation of those resolution, the posters. Then they have to affix in the walls of classroom that posters. Then they have to analyze and elaboration different comments about poster. Each student must analyze each poster and wrote in post-it their doubts, their comments, their questions, and so on. Then they collect the posters and the post-its, and in group they discuss and they try to answer those questions. And finally, the gallery walk finalize with a collective discussion where all students present their posters and present their posters, and students can make questions, and the teacher highlight some ideas during that discussion. We can see, you can see some of the work of the students during the gallery walk, solving and doing the posters. Here they are answered to the posters with their post-its. This, for example, I show you here one of the tasks that we propose with this pre-server teacher that can be used with their own future elementary pupils, and the problem is to find the area of shade part. In this poster, we can see what we call analytical solution, use of formulas and procedures, following the traditional way of to solve this kind of problem, and it was the most common. The other, we consider that is presented a visual solution where students look for the visual properties of the square and using fractions in a easy way they get the solution. The results allow to conclude some ideas that we can say that these tasks allowed to identify the strategies used by the participants and to verify that although they continue to resort to routinized formulas and procedures, they also appear the visual solutions. The gallery walk allows students to be engaged in peer resolutions and classroom discussions, clarifying doubts and increasing the individual repertoire of solution strategies. Students react positively to the gallery walk by expressing interest, motivation, and recognition of its importance in mathematical learning at any level, and it was an enjoyable and rewarding experience for all. To finalize, we as a mathematics educator must design teachers educator programs that should include experience that stimulate preserve teachers, stimulate preserve teacher knowledge, solving the same tasks and using the same teacher and learning principles that they are expected to use with their own future students. Thank you very much for your attention.